We're looking at the Torque Practice 2 set of problems here. In these problems on the sheet, we've got a pipe wrench kind of turning a bolt, a man lifting a beam, and a horse pulling a pull. We're going to break this up into a series of videos so you can kind of chunk and see each piece as we go along throughout the course of the week. We're going to look in this video at the very first problem, though, the pipe wrench being pulled by the hand. And in this problem, we've got a pipe wrench here. And it's pulling some sort of nut or bolt, or it's rotating one. So this here is our pivot. And when we look at torque, our torque, tau, it's equal to a moment arm crossed with some force. What this means is it's a moment arm multiplied a force multiplied by the sine of the angle between that moment arm and the force. So what we have here is we have our pivot in orange, and our hand is acting on the actual wrench itself out here. Now, the entire distance of this wrench is 1 foot, and we're given in the problem that this hand is 0.33 feet away from the edge. And with just some simple subtraction, 1 minus 0.33 gives us that the distance from the pivot, which is what we care about here, or rather, if I kind of drew this better, our pivot is right here at the edge. The distance from our pivot, this line, to this line is just 0.66 feet. So this right here, from the pivot out to the hand, this is our moment arm. That's our moment arm vector. Now, the hand itself, it is pulling at an angle of 50 degrees up and to the right, just like that. Now, while that might say, hey, look, I have a moment arm of 0.66. I have a force here of 7.5 pounds and an angle of 50. Maybe I just use that. Maybe that's fine. That's actually going to give us the wrong answer here. Whenever we look at this angle, because we do have an R and we do have a force here, the 7.5 pounds, to find the angle, what we do is we're actually going to shift our force vector over to the pivot. So if I redraw this real quick, here's our pivot. Here's the moment arm going directly to the right. I'm going to take this force vector, and without rotating it, just by translating it, so sliding it across the page, I'm going to bring it so it points like that. So that's F right there. This is R right here. And as given in the problem, this force vector made an angle of 50 degrees to the vertical line. I don't want that angle though. The angle that I want is from R to F. It's R cross F. So I want this angle right here. Well, if you know that between the vertical and the horizontal is 90 degrees, if this upper angle here is 50, that means the lower angle has to be 40 degrees, and that's what we're looking for. So for our equation here for torque, we can say R of 0.66 times the force, which we have as 7.5 pounds, times, and then we need that sine of 40 degrees. And that will give us our answer. Pull out the trusty calculator. Let's just throw this in real quick. 0.66 times 7.5 times, and make sure you're in degrees for your mode. So we are in degrees here. So times the sine of 40, and that gives us a value of 3.18, and that's going to be foot pounds as our unit. And that's our torque. There it is. Not too bad. Hope you enjoyed it. Check out the next one. If you're having some problems with that, it's the same idea. You're looking for a moment arm, you're looking for a force, and then you're trying to find the angle between them by shifting that force vector over. Take it easy.